15 cantilever beam made of A36 steel. I want to determine the displacement at point B of this material, okay, and it's loaded as shown. So what I do is I use superposition. Basically, I use a beam that's loaded in the center with 4 kips and a beam that's loaded at the end point with 6 kips. Basically, find the deflection of the end point for each one of these situations, and then add those together. So if I look up in Appendix B, I can find that the deflection at the end point for a load loaded at the center with 4 kips is given by this equation right here. So I plug in 4 kips, I plug in 12 feet, and I get the following answer for the deflection. We'll plug in EI in a little bit for our specific beam that we've got here. Now for it loaded at the end point, the deflection at the end point is PL cubed over 3EI, where again P is now 6 kips, L is still 12 feet, and I can find the deflection due to that 6 kip load. Now all I do is I add those two things together, and I get 4,176 kip feet cubed over EI. Okay, so now I can plug in EI to actually find the displacement in the results that I'm looking for. Okay, so I is 689 inches to the fourth, and again I'm getting this knowing that it's W10 by 15. So I look up in the appendix that has that stuff, which I believe is Appendix B. Okay, look up that specific beam, and it's A36 steel, so E is 29 times 10 to the third. Okay, so with those two values, I can actually find the displacement. Okay, using this, and again, this 1728 is times 12 to the third to go from cubic feet to cubic inches. Okay. When I do that, I can find that the displacement at the end point is 3.6. So again, we use that appendix in the back, Appendix C, to split this beam up into pieces that I can figure out what I'm looking for, and then basically add those pieces together to get the total answer.